In this example, we are going to learn how to calculate the Liquidus projection of a ternary system. Liquidus projection is one of the important types of phase diagrams. It is projection of ternary liquidus univariant lines into a two-dimensional Gibbs triangle, usually at constant pressure. The phase name in each area outlined by the univariant lines represents the primary phase solidified from the liquid. The isothermal contour lines on the Liquidus projection indicate the liquidus temperatures at compositions along the contours. In this video, we will use the aluminum-magnesium-zinc ternary system as an example to demonstrate how to calculate a liquidus projection and how to visualize it. Similar to other phase diagram calculations, first create a workspace with the PanPhaseDiagram module project and load database. Select the aluminum-magnesium-zinc TDB file. Select all three elements. For liquidus projection calculation, click this icon or go to PanPhaseDiagram. Select Phase Projection. In this window, you can set different projection calculation conditions. For example, we want to include the isotherms. The temperature interval uses the default value of 50. Here you can also change the default axis. Use different components as x-axis and y-axis. The default target phase is liquid, that we call it liquidus projection. But here you can also select any other phase as the target phase to calculate the projection of the selected phase. We use the liquid in this example. We want to see the subsystem and 3D diagram, so click both of them. Double-check the condition and the units, then click OK. Start calculation. In Pandat, after the liquidus projection calculation, two default diagrams will open. One is the liquidus projection plotted as a Gibbs triangle phase diagram. The other is the 3D line graph. The x and y axes are the composition of two components. The z-axis is the temperature. The blue lines are the univariant reaction lines. The green lines are isothermal lines. You can rotate it by clicking and holding the mouse. This is a typical liquidus projection diagram. We can label the primary phase regions using the label function. These color lines are isothermal contour lines. Put the cursor over the line. You will see a hint description about this line. Pressure F2 on the keyboard. The temperature of this isothermal line will be added. We can also add the temperature of other isothermal lines. In Pandat, more information is saved in tables. The data of the univariant reaction lines are in the default table. The invariant reaction table contains all the information about the invariant reactions. It contains the temperature, reaction, phase amount and phase composition for each invariant reaction. The isotherm table contains the isothermal contour lines data. Now let's double-click and open the default table. Select X aluminum and hold the Control key and select X zinc as Y-axis. Continue holding the Control key and select temperature as Z-axis. Then click this icon or go to the table. Choose Create 3D Surface Graph. This is the plotted 3D diagram of liquidus surface. From this video, we learn how to calculate the liquidus projection, label the primary phase regions and isothermal lines, and how to plot and view a 3D diagram from the table. That's all for this video. If you want to learn more about Pandat software, please visit our website or our YouTube channel.